All right, so we have started our recording session today. So everyone, I want to welcome you today to today's workshop. Today we are doing our What is in a Color workshop. And my name is Maggie Roberts. I'm the STEAM in the Classroom Program Coordinator with University of Illinois Extension and 4-H. I am here in McLean, and we have a couple awesome volunteers who are going to be leading our workshop today, and they are from Illinois State University. So I'm gonna stop sharing my screen and go ahead and just hand it over, let them do their own introductions here for you.
Okay.
Yep, thank you for having us. So Kevin, me, and Anna, we're going to be the volunteer leaders for this workshop. And so you can see there's a little time schedule there. It's a little rough. Don't worry if we go a little over or under, but that's just a rough estimate of what we're doing. And before we get started, we'll do some introductions first. So I think us two, we'll start the introductions. So my name is Kevin Diaz. I am going to be a junior this upcoming year at Illinois State University. I'm 20 years old. My favorite class back in middle school and high school were science classes, particularly chemistry classes. And I still really enjoy them, enough so to be a chemistry education major. And so that means I'm kind of working towards a degree to teach chemistry. And that's like my plan so far for the future.
Yeah, my name is Anna, and it is my second year at ISU, but I am a transfer, so I'm going to be a senior this year. I am also 20 years old. My major is actually biology teacher education, but I'm hoping to get an emphasis in chemistry and middle school education as well, so that I can teach all sorts of sciences in high school and middle school. My favorite class in school was actually chemistry. I learned chemistry 1 year and taught it with
I probably don't have whatever credentials.
Sorry. So yeah, chemistry was my favorite class in school. And yeah, so we're going to open it up to you guys if you want to unmute, and you guys can just tell us your name, your age, and your favorite class in school.
Video is not running, but your mic is on.
Is this one?
Hello.
Can you hear us?
Yes.
I don't know
Okay.
if that rings a bell.
We can hear you if you want to go ahead and introduce yourself. Your camera is not on, but we can hear you.
Oh, okay. My name is Dita. I'm 10 years old. I'm about to be 11 in September 16th, and my favorite class is science, because I really like how
Gita, are you still there with us?
yeah,
Okay. Is that all?
yeah.
So you really love science. That's great. Okay, thank you so much. Okay, anyone else?
Yeah, my name's Dion. I'm 13 and my favorite classes in school is like math and science. Yeah.
Awesome. And if you don't have any audio with you, or if you prefer not to speak, you can always type it in chat. We'll share it out loud with you guys as well. But we would like to hear your beautiful voices.
Okay. So the question that we're all really kind of looking for, our driving sort of question here is, do all marker brands have the same formula? So that includes, you know, Expo markers, Sharpie markers, Rose Art, Crayola, all the kind of markers. So we're gonna start to set up our experiment right now, and I'm just gonna turn my screen a little bit, pop it down here. So what you guys should have is a coffee filter, and I actually cut mine in half already. So what you're gonna do is you're gonna cut it in half, and you're going to cut little strips in it. So I'm gonna finish up those strips. I started them right earlier. So I'm gonna cut those out.
So yeah, right now we'll kind of start setting up the one of our experiments. There's a visual there with some instructions. Anna, if you look at her tiny screen, because right now you see the PowerPoint with the instructions, but if you choose to look at her, what do you call it? The instructor scene, you can see that she has a nice camera angle set up, kind of showing you what to do, so you can like follow along with her as well.
Yeah.
But she basically mentioned it. Do all marker brands have the same formula? And we're kind of looking mostly at Expo, Sharpies, and some other marker brands you might have lying around the house. So if you have any questions, if you need help setting this up, feel free to ask. If you have anything you need, any clarification, you can ask us. And yeah.
All right, so the first thing I'm gonna do is markers. I'm gonna use an Expo marker for the first one. And what you're gonna do is literally just up from about an inch from the bottom, you're gonna just put a little dot of your marker. So if you guys can see it, oh, it went on my table. You guys can see it, it's not on the very bottom, it's up a little bit, and you want it that way because you don't want the actual marker dot to touch the water that we're gonna put it in. So you're gonna do that with all of your markers. You should have an Expo and a Sharpie and then 2 other markers.
Yeah, feel free to also, if you haven't introduced yourselves yet, you can do that through chat. If you're working on this experiment, that's okay. Just go at your own pace. You do want to make sure that your glass, your cup of water, that the dot, where you put your dot, doesn't touch the water at first.
Yeah.
So I
My
think
2
that might be in
glasses
the
of water
instructions.
here. Yeah. So I've got these 2 glasses here, and I just have them about halfway full of water, so that, you know, you can put these in the glass but not have the dot touch in there. And what you're gonna do is you're gonna grab any other like pencil or marker, and what you're gonna do is you're gonna wrap the top that doesn't have the dot on it. You're just gonna wrap it around that marker. And for some reason, the only tape that I had in my house is Mickey Mouse tape. So I'm just gonna use that to secure this coffee filter around the marker here. I'm just gonna put it right there. And you should have, you can be able to fit 2 of these sheets per glass and per like the holder pencil that you're gonna put on there. You're just putting it around. All right, and so when you guys have your first 2 done, you can just go ahead and put those in the water. You just gotta make sure that it's touching the water. I'm gonna put a little bit more in here, because you want both of those coffee filters to, be touching the water, but not the dots. You don't want the dots to touch the water. Okay. So you guys can, that's not gonna touch. Okay, so we're just gonna continue, put that second one on. That should work. Okay.
Everyone at home doing all right?
Awesome. So as we're letting those develop, we're gonna ask a few questions here.
Yeah, Dion, that looks great.
Okay, so the first question we're going to ask is, what do you think is going to happen? So you can either type in the chat or unmute yourself and speak if you want. But what do you think is going to happen specifically? Do you think that all of those pigments that we put on those sheets are going to move or stay where they are on the paper?
Or do you think anything is going to happen at all? That's really up to your intuition.
Could you explain what pigments mean when it says all pigments are moving?
Right, so in any of these markers that you're looking at here, the ink that is transferred to the paper that you draw with is considered a pigment, and there are either one pigment or many pigments in a specific marker that is transferring. So that ink has those pigments in them.
Yeah, sorry about that. Thank you for the clarification.
So do you guys think that those of pigment and the ink, do you think those are going to stay where you put them on the paper, or do you think they're going to travel?
I got one chat message saying that the black is going to spread up to the top.
Okay. That is certainly an idea. Does anybody else have any?
Or do you guys all kind of agree with that idea that the black will move up?
Here's another question. Do you think that that black is going to move up by itself, like in just that whole dot? Do you think it's going to stay together?
No.
No? What do you think is going to happen? Do you think it's going to move itself, or?
I think it'll like spread instead of like staying in one dot. It'll spread throughout the copy filter.
Yeah.
Okay. You think it's going to separate a little bit?
Mm-hmm.
Okay. So this is what kind of we're looking at here is some of them are going to spread and some of them aren't. They're going to stay together. And the reason for that is that some of those marker pigments are hydrophobic and they push the water away from themselves. So you're going to see that some of those markers aren't going to move and some of them are, because they're taking the water in and moving with the water.
Yep.
So yeah, what do you guys think are gonna happen to the dots on the paper? We kind of answered that a little bit, but why? Why do you think that those dots are gonna spread because of that? So do you guys think that the sort of reason that we just said with the hydrophobic, hydrolytic, do you guys think that those are the driving reasons? Do you think that's it? Sorry. Do you think that the reason
Scared
is
of water. If it's scared of water, is it then going to run away from the water? That's what I think is going to happen, because I run away from things that I'm scared of.
So like the dot's probably going to spread if it's like hydrophobic, and it'll probably stay if it's the other thing, hydrophilic. Yeah.
yeah. So you think
Okay.
it's gonna spread if it's hydrophobic, and you think it's gonna stay together if it's hydrophilic?
Yeah, I think.
Okay. Okay. Dita, what do you think?
I think the same thing. If it's hydrophobic, then it's gonna run away. And
Okay. Okay, so if you have, the water and the pigment, if the pigment is hydrophobic, it's going to push the water away. So it's not going to, what's happening here is that, the pigments that are hydrophilic, that love the water, are going to travel with the water. And the ones that are hydrophobic are going to push it away because they don't want to move.
It's
Okay.
kind of hard to see kind of with like the visual we have, but if you think about just ink on a piece of paper, whether it's Sharpie, whether it's Crayola, it's not going to move without any water, right? You can't hang a piece of paper and, oh no, the ink all fell out. It's going to stay in the paper, right? That'd be pretty crazy. You have some crazy paper if your ink does that. But because we're adding water to the coffee filter, right? The water is moving up through the paper. The ink and the paper, sorry, let me rephrase this. The ink is already kind of dissolved in the paper. There are some spaces in the paper. They're super small. You can't see them. It's really small. And that's why ink doesn't fall off paper. But we're adding water to it. And so the water's traveling up. And when the water's traveling up, if you guys have some of your setups already developing already, and you can see the water moving up, some of those inks are traveling with the water. They're mixing with the water. They're not staying away from the water. They're mixing with the water. And so that can be kind of confusing, right? Because you don't think of ink mixing with paper, ink mixing with anything. You just think of it as ink staying on the piece of paper. And so with the water, the ink and the water are actually mixing into like one solution, so that way they can travel up the piece of paper altogether. Does that make sense? Does that kind of help this idea? Because this is a very advanced idea. This is really hard science. So I hope that helped.
So, so if you guys look at your papers, at your coffee filters, do you see that there some of those marker dots are separating?
Mhm.
Okay, so why do you think those colors are separating?
Mhm.
So like, if you look at mine here, if you guys can see it, there's different colors in those specific dots that I had. So why do you think this color, it started out as black? Why do you think that it's not very black anymore?
Because it's all
Because it all what?
wet and inky, because it's like drooping down a lot and it kind of loses a little color.
Okay.
Okay, so it's like a little wet, and so like it loses some color is what you're saying, right, Dita?
Yeah.
Okay. So there's definitely something with the water and the ink, because like I said earlier, if you just have ink and paper, it's not going to happen. Nothing's going to happen. But with the water and ink, there's some smearing, like when you drop your notebook in a puddle, or like when you spill water over some paper, you sometimes have that ink spilling. And so this is definitely an example of this, but we kind of want to explore this idea of why do you think the water is separating the colors? Is it like something to do with the hydrophilic idea again? Or is it some innate, some property of the inks, or what we referred to earlier, the pigments, some property of the pigment that is making that with the water is separating into different colors? If that kind of helps to clarify the question.
Like yeah, I tried Crayola and then the Arteza thing. So I saw Crayola, it started spreading and it turned more of a green blue rather than this like what it was. So yeah, I think it's like the properties in the like the formula of the ink that causes it to either like stay or spread in the water.
What property do you think that causes it to do that?
I'm not sure yet,
Okay.
but
Okay, so I'm going to introduce a concept here that can be very useful. So certain inks and certain colors, even on like the light spectrum, are heavier and bigger than others. So this may not apply to everybody, but it definitely helped me see it. So I actually dyed my hair red once, and it was very difficult for me to get the red out of my hair. So in that process, that red is the largest pigment, and it gets stuck in the hair follicle. It won't move, it won't get out. So if you consider that red is the largest color molecule, what do you think is the smallest on that, you know, the typical range from there, red, orange, yellow, green, blue, purple?
probably like the like yellow or something.
Okay, okay. So if red is the largest, then what's the opposite of red then?
Oh,
Ida, what do you think?
Mm,
Any idea?
I don't know.
Okay.
Yeah, it's pretty tough.
Yeah.
This is like really hard science, and so just being able to like at least kind of think about it in your head, it's kind of helpful. And so with what we're trying to get to with this question is to have you guys think about dyes and colors and what makes up markers on like the atomic size. Do you guys know what atoms are, right? Or no?
No.
Yes, I see Dion nodding. I
Yeah.
know he knows.
Yeah.
So they're like the little bits of matter that make up everything in our world, whether it's solid, liquid, or gas, right? And they're really small and they make up everything. You
Yeah.
got that part down. And so a lot of these color dyes have different chemical formulas, or they're made up of different elements. Some of them are really small. And others of them, other dyes, other colors are very big in atomic size. And so sorry. If you think about atomic size, and if some of them are really small and others are really big, like Anna said, do you think that might be affecting what things are being separated? Or do you think, oh, it doesn't matter if it's super, super small or medium small? This is not to scale, by the way, because it's a lot smaller. But do you think the size of a color matters into separation, or might be able to explain why it's separated?
Well, maybe, yeah, I guess.
Okay.
Oh.
So I'm gonna continue. So if you guys look at your chromatography is what we call this, chromatography. Your colors here, what colors are you seeing?
I know Dihan said the Crayola separated into blue, green, right? Something like that.
Yeah. Yeah.
Did you get any colors to separate, Dita, or were you not so lucky?
Oh, my Crayola completely faded. Like it's gone. The Crayola.
Mm-hmm. Yeah, so that'll happen if you let it develop further than you can kind of see. It spreads out too much. So with mine too, where the whole line up here is where it ended and everything that was separated kind of just disappeared a little bit. And that'll happen. It depends on how long you leave it in the water, for sure.
Oh, okay.
I have a question for you, Dion. Could you tell me, from looking at your Crayola marker, does it say that it is washable?
No, it doesn't say that. It's just a normal one.
It's just a normal Crayola. So I think, though, as far as I know, I think all Crayola markers are actually washable. I know they have a separate brand that's like considered ultra washable. Yep, see, Anna has one there that are washable. So I wonder if that has to play into like how you were saying the color just completely disappeared. It was like it was washed away.
Right, yeah.
Yeah, that's a great question. I think when we mostly talk about washable markers, we only think about it like on our hands, right? Because you're in elementary school, or maybe you're just in middle. I used Crayola mostly in elementary school, but my hands were full of markers after any crafts. And so my parents were like, oh, this brand is a little bit more expensive, but you get the washable, so you can wash your hands and get it off your hands completely rather than taking a minute or two at the sink trying to scrub it off. And so, yeah, maybe washable and permanent markers like Sharpie, maybe there's something different between that. And we might get into that a little bit more later, actually.
Okay, so if we consider, what we were talking about with the larger molecules and the smaller molecules, do you think that this experiment would work with a different paper, like construction paper? Or I have a sheet of paper here. It's made out of stone, like crushed stone. Do you think that this experiment would work with a thicker paper?
Uh,
That was the wrong number.
You chose the wrong option. So can
Should I
you,
make 37 again?
no, can you share your,
Um,
and can you go to our control?
What do you think, Dita?
um,
There's no wrong answer here. You can just say whatever you're thinking.
Here, which one did you choose?
This guy in the middle.
Yeah, that's the wrong one. So we choose the top one. I mean, the middle, the second one.
This one?
Yeah.
Where?
Because you see,
maybe, I'm not
so there's a difference.
sure.
If you, the, what's the,
Okay, maybe it might work.
now, and the second one is activate.
Okay.
Right? So what you're trying to do is just the
Do you-
Dion, I saw you kind of unmuted yourself earlier and then you went back on mute.
I think like it wouldn't work like on thicker paper like cardstock or something. So probably it's just that the coffee filters are like really thin,
Mhm.
and anything can pass through it pretty easily. So
Okay. So what about like we used water in the glass. What if we used different liquids? Gatorade, rubbing alcohol. Like what kind of do you think it would work with other liquids?
I don't know why rubbing alcohol would be different. Why? But would any liquid work, right? Like, do you think there wouldn't be a liquid that would not work? Would, like, I don't know. I think it might work with everything. Do you guys agree with that any liquid might work, or, oh no, like, it clearly wouldn't work with this or this?
I think any liquid would work because like the ink would just still pass through the ink would still like fade in the liquid. So yeah, I think any liquid would work.
Okay, so I think I was sorry, I completely lost my train of thought there. I think if you think about it, kind of what happened, what you observed during this experiment, right? You saw that water traveled up a piece of paper, which we kind of agreed on was very important. Do you guys agree that the water with the paper and the ink, those are very important elements to this experiment? The water traveling up the piece of paper was very important, right? Yep, I see Dihan kind of nodding. Do you think that, like, if I had honey, would honey be able to travel up a piece of paper? Do you think honey could do that?
It would take more time probably, but it could.
Yeah,
Because
okay.
Yeah.
Have you guys heard the term density before?
Yeah.
Yeah. So the density of water and the density of honey are very different, right? So the density of water is 1, I think, right? And so it is able to resist that pull of gravity because it's not as dense as some other liquids, right? So the density of the liquid that you use has to be pretty light, right? It's got to be not very dense in order to travel through the gaps in the paper. So honey would not necessarily work, but different liquids like rubbing alcohol is actually supposed to be able to remove Sharpie marker, which is hydrophobic. So it depends on the density of those liquids. If it's too dense, it won't travel through that paper because it always takes the path of least resistance, right? To go where it can go, not doesn't have a want to go anywhere. It just can go somewhere, right? So that water is not very dense and it can go through more places in the paper, whereas honey wouldn't go very far, right?
Or like what you said, Dihani, would take a lot longer because you just kind of know from common sense, honey is a lot thicker, a lot heavier, a lot denser, like Anna said. So you were on the right track.
Question. So why do you think that, the Expo marker and the Sharpie, at least on mine, those two didn't move? So you still have them there. And the Crayola, and I used Crazy Art, those two did. So why do you think that these two didn't move and these two did move?
Yeah, and it might come back to the washable marker again. That might be important here as well too.
Like probably it's like the elements of the like each different ink brand. Probably like others are stronger, like permanent ones, while Crayola and others are like weaker. I guess I don't know.
Okay, for sure. So why do you think that Sharpie makes that claim of permanent, right? Why do you think that it is permanent? What makes it?
I think I heard you say something about like elements earlier, right? Or like,
Yeah.
Mhm.
yeah, and I think I heard a little agreement from Dita too. I'm not too sure, but it's 100% kind of like the elements and what make up the marker, right? At that atomic, at that super small level. Just kind of like how you use different ingredients to cook different things. Some of these markers have different ingredients. They have different like elements in them, different molecules that maybe with the Crayola, that one's is washable, but then Sharpie, they might add or use a different ingredient or element to make it permanent. And Anna and I, we only know that that's the reason. We couldn't tell you what that element is or how they make it do that. But it's very advanced science and it's really cool and interesting to kind of see how the different ingredients, the different molecules kind of make markers different from each other, right? And you saw that with some of them separating, some of them moving up with the water, and some of them not. So,
Yeah, so I'm gonna click on this video here and we're gonna show you how, like, why the liquid matters and why the paper matters. It's a loud and fun video, so we'll click on that and show you guys.
and it's kind of an analogy to kind of understand dyes moving up or traveling.
Can you guys all hear it? I don't really need to. Can you see it? make sure you guys notice the size of the people going through, right? And their speed.
Oh man. Did you see that guy? He hit like all the lasers on that jump.
And this last one is they're just running through it to get all the lights off. So, okay. So what did you guys notice about the size of those people going through and their speed?
Some of them actually tried to, while others just ran through it.
That's true. That's true.
And
Yeah.
yeah, size makes it like either more or less difficult, like flexibility and size and speed.
Yeah.
Um,
So do you think the smaller kids or the bigger kids? Do you think which one was faster going through, do you think?
When they did it correctly, not when they were running
They
through.
were running through.
well, I think, yeah, it's just like the smaller kids. I mean, they did make some errors, more errors, but I mean, they were faster going through.
Exactly. So we can kind of see, you know, that laser maze, we can kind of see those lasers as the fibers in the paper. Because if you look real close at that paper, you can see that it's not just a sheet, right? You can see that there's little pieces in there. You can see through it, and there's little fibers in there. And those fibers are like the lasers in the laser maze. And the people, whether they were big or whether they were small, are like the colors. So with those red molecules being the bigger kids and the blue or the purple molecules being those little kids, right? You can see sort of on this one for sure that those reds are staying lower and those blues are getting really high, right? So the blues are moving farther and faster than those reds are. Can you guys see that on yours?
Yeah.
Yeah, nice. Okay, so why do you think that these black markers, why do you think that they're not just black markers?
Like I think a lot of companies and a lot of groups, they all make the same color, but it's made up of like different colors.
Right.
And so kind of thinking outside of science too, and it doesn't have to relate only to science. There might be some other reasons why they don't just make a black. Like, have you guys seen a color wheel, like in an art class, right? The art wheel, like a red, and then it changes shades, goes to like green, and then blue and purple. Have you guys ever really seen black on that? Is there black? I see some shaking head. I've never seen an art wheel with just black. And so do you think that might, why do you think there is no black on the color wheel? Do you think,
Well, actually, it's because like black's more like a shade rather than a color. Like, some of my like art teachers classified it as like a shade rather than an actual color. So, like white and black, they didn't say they were colors. Probably that's why it's not on the color wheel.
and so maybe it's like not easy to make, right? If it's, because you can grab a red pen or like a red marker, but do you think it's easy to make a black color by itself, or in a factory or in a lab? Do you think it's easy to kind of make that if it's like what you said, Dihan, not technically a color, but like a shade?
So you guys know that, you know, you usually buy a pack of markers, right? And they have all of these colors in them. And not all of those colors are, you know, just plain black, right? So what do you think they, like, the expenses, like money wise? Do you think that it's less expensive for them to use the colors that they already have formulated to make another color? Or do you think it's more expensive?
Well, it's probably like less expensive because you can just like mix colors to make like secondary colors. So
Right.
probably less expensive.
Right. So I think that's, for me, that's one of the bigger reasons why they use those colors that they already have, right, to make another one. All right, so let's move on to the next question. So these are, when I did this prior, these were my results here. You know, the Sharpie and the Expo, they didn't move at all. And then the Crayola separated into a nice separation between warm and cold colors. And the Crazy Art did as well. And what you can see with the Crayola and the Crazy Art is those warm colors, the reds and like darker like oranges and those colors, they stayed towards the bottom. And those colder colors, those blues, they went, you know, further up the paper, which kind of, you know, tells you about the density of those pigments, right? So next, we're going to look at how you can apply that to agriculture, right? So I have a leaf of spinach here. Do this again. So I've got a leaf of spinach here, right? And what we want to do with this spinach is we want to take the stem off. So what you're going to do is you're going to tear the stem so that half of that leaf is separated, right? So you still have half of the leaf on there. What you're going to do here is you're going to roll this actually to make like a pen, sort of. So you're just going to take the edge of it, and it's a little difficult. You're just going to start rolling it. I just use one finger because it's easier. So now you've got a little sort of pen, right? And you're going to take your coffee filter. If you need to cut another one, I can wait for that. But what you're going to do here is you're going to use this spinach as if it was a pen, and just, you know, an inch up from the bottom, you're going to rub that onto the paper.
Yeah, and also if you guys have a coin or something like that, I think that might have been or something hard you can press on, you can use that to kind of rub some of that spinach onto the filter paper, or even your nail. You could probably just try to scratch it on to the filter paper.
Exactly. I'm just going to make sure that this is going to be able to touch the bottom there. All right. So you're going to do the same thing, just making sure that the actual pigment there, making sure that it doesn't touch the water. Yeah. We're going to let that develop. So I've got mine right here. You're going to make sure that you remember the bottom of the water, or the bottom of the paper has to touch the water, but the pigment cannot. You're just going to wait for that to develop there, okay? So, so do you think that there's going to be one or more color in the spinach? Do you think there's just going to be one, or are there more?
One.
Do you think
One?
there's gonna be-
I'm gonna stay as one color. Oh.
Okay.
Do you think that the spinach is even going to move, right? Because we were talking about how markers are really small in the filter. Do you think that spinach might be a little bigger, or that might not like water, like we said earlier? Do you think any of that might happen?
I just got a chat message saying that since the spinach is green, they think that blue and yellow will come off of the spinach.
Yeah, that's awesome. Like going back to that color wheel idea, right? And blue and yellow make green, so that would make sense. I like that thinking.
Okay, I'm gonna go to the next question here. So have you guys learned about the pigments, the coloring that is in plants? No, yes.
I'm sorry, could you say that again, Dita?
What?
Did you say anything? No, I must be hearing things then, sorry.
It's okay.
Dion, have you learned anything about pigments in plants?
Well, yeah, there's like chlorophyll that makes some of them some of them green, like leaves or grass, and yeah, that's probably that's the pigment in like these green plants, chlorophyll.
Yeah, awesome. That's exactly right. So there's two different kinds of chlorophyll in most darker plants, chlorophyll A and chlorophyll B. Let me see if I have it. Yeah. So here we've got, chlorophyll A and chlorophyll B. And then there's also two more pigments that spinach has. So carotene is in there, and then also xanthophyll. So those are different kinds of pigments that spinach actually has that you can separate. And so mine's separating a little bit slowly, but this is a great picture of it, where you can see that the chlorophyll B is a little darker than chlorophyll A. And then xanthophyll is a kind of orangey yellow, and carotene up the very top, that's a yellow. So whoever said that, the blue and yellow was a very good, very close. There is for sure yellow in there. So yeah, so when a plant has those pigments, so instead of just the one chlorophyll, right? We said that it would have chlorophyll. If it just had that one pigment, it wouldn't be able to capture as many wavelengths of light. So you know how light has wavelengths of color in the light spectrum, how white light has all of those pigments, all of those colors in them. So with those different pigments that we see here, it's able to capture more light because it has those different colors. And so by doing that, it increases the plant's efficiency of creating more food for itself, all those sugars. And those darker plants, those shade-loving plants, they have more pigments because not as much light can reach them. So they have to have that wider range of colors to produce enough food for themselves, right? And so there's a lot of, before markers were made or before t-shirt dyes were made, we used to use plants. And so a lot of those plants have different dyes in them, different pigments in them that we use to color shirts or clothes. And so you can see here on the right is a clearer picture there that red was used with mostly beet products that produced a really bright red. And pomegranate juice did the same thing. And that orange, carrot juice, carrot powder, paprika, and all of those different pigments there that we could use to dye really anything we wanted. So it's very, very useful, to have those different pigments in the plants, and it's useful for us. So the more that those plants would reproduce, the more that we'd be able to use them, right? So we actually had this told to us recently. A lot of, languages, pigments really affect our language as well. And a lot of languages near the North Pole, they don't have a word for blue because the sky there isn't blue. I think it's more of a gray or color. It's not very blue. And so the languages in the North Pole, they don't have the word blue. So they're like, what? I don't know what color that is. What is that? So those languages, they don't have blue in them. And so here's a picture of, the Aurora Borealis. Has all these different colors, and there's some blue in there, but it's not as frequently seen.
Yeah, and that also relates back to what you see in nature, because you see a lot of green. Green is grass. Green is corn, fields. There's so much green.
Right.
Sometimes it's too much. But you never see a lot of blue flowers. You never see too many. It's mostly blue flowers, but
yeah,
some of those rare flowers and plants like purple, red, we had to work a lot to kind of harvest these flowers to get these pigments that we wanted so we could use them. And like Anna said before, we had the chemistry, before we knew all the ingredients, the elements, right, to make these colors. We had to get them from plants, and purple plants were like never around. There were like never blue plants. So back then, things, I guess, weren't as colorful as they are now.
And so when you see a lot of those, royalty colors being purple, it's because of the rarity of those dyes, right? So there were very few dyes that could produce a purple color, which is why that rarity produced, purple being the royal color, right? So the colors that don't show up as often are considered more valuable to some people, right? And then even, so back here when we were talking about plant efficiency, in farming, right, there's a lot of places where they can't grow plants outside. So they have to produce them inside, right? They have to have light gardens or aquaponics where they can't produce plants outside. They have to use those wavelengths of light more efficiently. So they have to be able to know, which plants need which light and which plants need which wavelengths to produce the right amount of fruit and vegetables and food, right? So knowing what wavelengths of light and what what those pigments in those plants are really helps to understand what lights need to be used to grow those plants.
Yeah, and I think that's all from us.
Yeah. So, yeah, you've learned, what goes into a color. Go ahead, Kevin.
Okay, I'm sorry, but
No, you're okay.
yeah, so that's this seminar, What's in a Color. So obviously, I hope you guys learned what's in a color. It's in the name of the whole experiment. You kind of understand why colors separate. It's definitely a challenging subject. You learned 2 new vocab words, hydrophobic, hydrophilic. You learned that kind of like the colors on the atomic, on the super small scale, they're kind of like ingredients, and different brands use different of those different amounts, different types of ingredients. And kind of ending with the spinach and the importance of the different colors in the plants and what those colors are used for and how plants utilize different colors. So I think that's all of it from us then. If you guys wanna, you can explore this experiment with different markers. If you have a red, a blue, I'm pretty sure you have different colored markers because having only black markers would kind of stink. But you can feel free to try with different vegetables, different plants too. I wouldn't recommend any nice flowers though, because I know my mom would kill me if I took a tulip from her garden and crushed it onto a piece of paper. So maybe ask for parent permission first. But yeah, feel free to explore this. If you have any other questions or concerns for us, you can stay after. You can talk about like the science behind it more if you want to know more. And that's all it is. Do you have anything else to add, Anna?
That is all good for me.
Right. Thank you guys for coming here. Thank you guys for staying live with us. It's kind of rough online. We would all want to do this in person, but we're trying our best. So, and you got to stay safe out there. So, good job, everyone.
All right, so I'm gonna hand it back to Miss Roberts. She wants to say anything.
Yeah. Okay. So thank you so much to Anna and to Kevin. I hope you guys enjoyed this workshop and you were able to learn a lot. I know I certainly enjoyed it. If you have any questions and you want to hang around for a little bit, they'll be more than happy to help you out with those questions, or if you have any additional experiments you want to try out and run past them, they'll help you out with that as well. Otherwise, have a great day and thank you for joining us.